So I've gone to modules, and of course we are doing experiment number 3, density, miscibility, and solubility. And you click on the information, you will see that these are the equipment that you need. I have it on my desk as well. And then we have the instructions here. The PowerPoint, you guys can read that. And then of course, what is this? This is the written directions. So between that and this, I guess I have 2. I don't know why I have 2 of these. Okay. Yeah, you don't need 2 of these. It's the same experiment. You can certainly watch the video of me talking about this experiment in the past. Remember that when you guys go to Canvas and you click on modules, you want to upload your right here, your Prelab in this section. Okay, this is what it looks like. You're answering these questions. You want to, these are different sections. That way, when I grade them, I'm consistent and I'm not jumping all over the place. And then this would be your data observations as well as your photo. And then this would be the PostLab. So this is the experiment itself. I've downloaded the experiment. And what you guys need to remember is that you guys are, this experiment will go pretty fast. Okay. There are 3 chemicals in your lab kit. It's called density, unknown A, unknown B, unknown C, and then you also have iodines. If you take a look at, these are typical substances and their density. Whenever a substance have a density greater than 1, then it's generally going to sink or be in the bottom if you have a aqueous medium, that is if you have water, and it will generally be on top if you have a water in there as well. So in this particular case, if you have ethanol or hexane with water, it's going to be sitting above the water. If you have something called dichloromethane, it's going to be below the water towards the bottom. So these are typical items that we've measured the density in the past. You guys are going to be using much more safe items. You guys are going to be doing cooking oil and I believe syrup. Okay, so right here it tells you that the density greater than 1, it'll sink. If it's less than 1, it'll float. You guys should also know when you put a substance in, if you're making a solution and you can dissolve more substance, like if you put salt in water, for example, and you put like a pinch of salt in like a pot of water, okay, let's say 2 cups of water, you put a pinch of salt, the water of course will be salty, and you can add more salt and it'll still dissolve. We call that an unsaturated solution. In other words, you can dissolve still more salt in that solution until you reach the saturation amount. Okay, when you reach the saturation amount, then 1 more crystal, 2 more crystals, and it won't dissolve any further. Okay, in fact, if you pass the saturation amount, okay, so that you're adding salt and you're putting it by the teaspoon and you start to see the salt collect in the bottom, the solution itself will be saturated because it's not going to dissolve any more of the salt. Okay, but if you wanted to trick the solution so that it can dissolve more of the salt, what you can actually do is heat it up. The heat will cause the salt to dissolve and then cool it back down to that room temperature. Now, what happens is that the crystals are confused. They should crash out of solution and form a precipitate, but because it was suspended in the water, okay, it's going to stay dissolved. What you can do is if you add a few crystals of salt right on that water that is now supersaturated. Supersaturated means that the solution is holding more than its capacity. Then if you add a few crystals, then everything, all the salt above the saturation level will start precipitating out, okay? But know the difference between unsaturated, saturated, and supersaturated. You can think of a good analogy is a classroom. It's got 24 seats, okay? There's 24 seats. I'm teaching a chemistry class and there's only 10 students. That's unsaturated because the class can still fit 14 students, right? 24 10s in a class, 14 students can still fit in. So it's unsaturated. But suppose that it's time when I'm calling attendance and I have 24 enrolled and all 24 seats are occupied, then that would be saturated. Now, if it's like the first day of class and students are trying to crash a class and I have more than 24, something like 32 in that one classroom, then it's going to be supersaturated. So that's what supersaturated and saturated and unsaturated means. Now, since we're talking about solutions, if you take a solid and you put it in water, like salt, then we say it's soluble. If you take sand and you put it in water, then we say it's insoluble. Insoluble meaning it doesn't dissolve. Soluble meaning it dissolves. Now, let's say that we don't have a solid, we have a liquid, like alcohol. We have alcohol, we take a little bit of alcohol and we mix it with water. Well, alcohol will mix with water. So when a liquid is going into a liquid, we call it miscible, okay? If, however, instead of alcohol, we have, say, oil, okay? Olive oil or some sort of oil, and we put it in water, you guys know that it stays apart. That's because you guys will learn that oil is non-polar, water's polar, so they stay apart. Well, when two liquid do not mix, then we say it's immiscible. So make sure you use those terminology in the pre-lab and post-lab questions, okay? When you have a liquid and liquid, don't use terminology like soluble, insoluble. You use terminology miscible and immiscible. When you have a solid in a liquid, then you have soluble and insoluble. So that's the experiment that we have for today. So if you take a look at the write-up here, remember you're taking 4 photos. It tells you what they are right here. The chemicals you guys are going to be using, cooking oil, syrup, and probably an ethanol or hexane. These hexane is a flammable and it's irritant. You don't want to drink it. Ethanol is also toxic in huge quantity, okay? But don't try and taste any of the liquid that you have. Your unknowns are going to be those. You guys will need test tubes, 10 mil grad cylinder, scale, okay? And then you also need to clean your graduated cylinder between runs, and it has to be dry, because if it's not dry, then it's going to affect the volume for your next liquid and also affect the mass. This is the worksheet that you guys are going to be filling. You're going to weigh the graduated cylinder, and you have 3 liquids. So weigh the graduated cylinder each time because it might be a little bit moist, so the mass might be slightly off, but it should be consistent with each other. Remember, we're using a 10 mil grad cylinder. So if we're using a 10 mil grad cylinder, you guys remember from experiment 2, which you guys are currently doing, that the precision of these graduated cylinder, the delta is 0.1. So you're reading it to the 100th of a milliliter, 0.01, because we're using a 10 mil grad cylinder, okay? So please keep that in mind, that when you read the volume, you're going to read it based on the precision of the graduated cylinder. And that means that you're actually going to fill it up. And if you need to take the bottom off, fine, do that. And you need to be at eye level, and then you're going to read it based on the meniscus of that liquid, okay? So you're going to do this 3 times because we have 3 liquid unknowns. You're going to do the mass as well, and I will show you how to do the mass so that you don't have to take extra steps. And then, of course, if you've got the volume and you've got the mass, then you can certainly calculate the density. And because these are different liquids, then they should have different densities. And then once you have them in the 3 separate containers, you only just need 2 test tubes, because the third one could be your 10 mil grad cylinder. That could be the third container. That way you could minimize in the glassware that you use. But anyway, once you have those, then you're going to mix it in such a way that the most dense is going to be in the bottom and the least dense is going to be on top. So you pour your most dense first, followed by your second, and then your least dense is going to be on top. This is your pre-lab question. Okay, it gives you, I don't know what that box is there for. That's not important, but let's see if I can erase that. These are the mass of the graduated cylinder. The graduated cylinder with the liquid, so you can basically by difference calculate the mass of the liquid. And then this is the volume right here of your liquid. You should be able to read that based on the precision that's shown, and then calculate the density. So this is right here is just your pre-lab, similar to the calculation you would do for the lab. And then right here, use your common sense in terms of what will happen when you take sand and you put it in a beaker of water, or rubbing alcohol and or grain alcohol and put it in what happens when you mix it. So if you're not sure about whether these chemicals are going to be soluble in water or not, you can look them up in the internet. Okay, so that's your pre-lab. It's pretty straightforward. This is your post-lab. The post-lab is going to be based on the data that you've collected, liquid A and liquid B. So make sure you label these things, because this is liquid A, liquid B, and liquid C. Okay, I'll show you that when I show you my desktop shortly here. Okay, and you're going to tell me whether it's miscible or non-miscible. Okay, lab 2 is unknown density A, unknown density C, unknown density B. And this is nothing more than water. Okay, you also need some Burrell pipettes. Now, what I have done for the sake of time, so that this movie will be much more smooth, is I've got a variety of 10 mil grad cylinder. That way I don't have to keep washing them. So with the weighing bolt there, it's 3.02 grams. I'm going to tare it. Now it reads 0. What you want to do is you want to get a clean graduated cylinder. Make sure there's no residual liquid in here. And then you want to weigh it. And the reason why you want to weigh it is because you want to determine the mass of the liquid. Okay? So right now I have a mass of 21.71 for the graduated cylinder. Next thing I'm going to do is I'm going to take liquid A, and I'm going to add enough of the liquid into the graduated cylinder so that I can read the volume. So I'm just going to take my Burrell pipette, draw some of the liquid out, and then carefully place it into the graduated cylinder. Make sure that you record the initial mass. So this particular mass now with the liquid inside is 22.18. The next thing that you want to do is you want to read the volume. In order to read the volume, you've got to wait till all the liquid, because you can see that I've got some liquid in the side, has settled. And again, you're going to see on your graduated cylinder, at least this one, it goes from 0 to 9 going to the bottom, but the other one goes from 1 to 10. So we're going to be reading that. Again, you need to be perfectly horizontal and you need to read that volume. And this particular volume is going to be read at about 1.50. If you only have one graduated cylinder, then make sure you read the volume first and then pour the liquid into a test tube. But since I have multiple graduated cylinder, I'm going to just get a second graduated cylinder and then I'm going to weigh it again. And then I'm going to take my second graduated cylinder, put the graduated cylinder in the scale, record that mass, and then take liquid B, draw some liquid from liquid B, and add it to the graduated cylinder. So I've got some volume here. I didn't use it all. I still have some liquid B here. Okay. And now I'm just going to close this, put this off to the side, read my new mass, 33 grams. And if I'm satisfied with that mass, I'm going to read the volume and then pour it into a second test tube. I'm going to put the third graduated cylinder onto the scale. I'm going to read the mass, and then I'm going to take a new Burrell pipette, open up liquid C, and again do the same thing. I'm going to draw some liquid C out, put it into the graduated cylinder, wait for the scale to settle down, and then read the mass. So now that I have the mass, I can now read the volume of it. So the next step is to find your most dense liquid. You take that test tube. In this particular case, I'm just going to use the graduated cylinder, and then use that as a starting point. Okay, your most dense liquid should be at the bottom. Next, find your next more dense liquid, and then slowly pour the liquid into the first so that it doesn't mix. And you can do that either using a Burrell pipette if you want, or you can just slowly pour the second liquid into the first down the side so that it doesn't mix. Next thing that you're going to do is take the third liquid and then do the same thing. Pour that into the test tube that has the two other liquid. And again, you want to be careful so that they don't upset each other. So now that the three liquids are mixed, and again, just allow the three liquids to settle. Go ahead and get liquids A, B, and C, and then using a Burrell pipette, add a few drops of the water solution into the three liquids. So we're going to take a few drops of A, a few drops of water into A, a few drops of water into B, and a few drops of water into C. Here we're going to see the miscibility of the water into the three liquids. Go ahead and shake each one of these up and see whether or not they mix. Shake it up, let it sit for a while. And as it sits, go ahead and take your cylinder with all three liquids and add water to that. Write your observation as to what happened. And the water in this particular case is blue. We put some dye, food coloring in the water. And the last thing you want to do is, again, write your observation as to what it looks like. And then shake it. Put a rubber stopper and on the test tube and shake it. Make sure it's well mixed. And then just have it settled. And then just wait a few minutes while the solutions start settling. Put your data on the data sheet here, okay? Draw a line to indicate the levels of the liquid. Before you mix, draw a line. Which one is A, which one's B, which one is C? Maybe C was on the bottom, maybe B was on top, and A is in the middle. You have to indicate that. Label the colors, okay? When you add the iodine, stopper it, shake it up, and redraw the different layers again. It looks like two of them do mix. So two of them are miscible. The third is not. Then you guys answer, hopefully you answer the pre-lab before you do the experiment. And then your post-lab is just figuring out A and B, which did they mix? Did they not mix? Justification. That's your observation. Liquid B and C, did they mix? Did they not mix? Justification, your observation. Liquid C and A, did they mix? Did they not mix? Justification. And then here, this part is, did the iodine go in A? Did the iodine go in B? Did the iodine go in C? Justification. Justification is always the evidence that you observe. That's why when you're actually doing these experiments, you want to write down your careful observations. That way you can write it here. And then this is just a question that tells you that you've got three solids. These solids could either sink or float. Maybe one is made out of wood, maybe another one's made out of more heavy wood. And it's depending on the density. And a bucket of water, if it's got a density close to water, it's going to hover right in the middle. If it's got a density less than water, it's going to float on top. If it's got a density much greater than water, it's going to sink. But a density that's close to water, even if water is 1.0 and the item's like 1.02 or 0.98, it's still going to hover in the middle. Okay. And then don't forget your photos. Told you this experiment is not difficult. The next experiment is going to be a little bit more involved, but this experiment's one of the easier ones.